Extension methods are great, but they can get messy. IntelliSense will pop up strange suggestions, dependencies will bloat your application, bugs will appear by magic when you update NuGet packages, and you'll still get duplicated code in your app, unless you follow some best practices. Hey, how you doing? I'm Elton, and this is Best Practices for Extension Methods, the next module in Pluralsight's C# extension methods. This is the module where you'll learn those best practices so you can make full use of extension methods without the mess. I'll go through several best practices here, and they're almost all in the area of design, thinking about what it is you're going to extend and how you're going to deliver your extensions. So really, these are design guidelines, which means, well, first, it means they won't fit every scenario. So if you can't see how some of these map to what you want to do, that's fine. You don't have to follow them to the letter. But it also means there can be a big cost in getting things wrong. If your extension methods are successful, they'll get a lot of use. And if you then find problems and try to change your design, you're going to upset all the consumers. So with those notes of caution, I'm going to lay out the best practice guidelines here, and this module will have plenty of demos to show you the rights and wrongs of extension methods. I'll start with the what. That's what you choose to extend. Developers tend to get carried away with extension methods and decide to refactor every bit of code which might maybe be useful into an extension method. Don't do that. The first guideline for extension methods is to use them sparingly. Only write extensions that you know will be used by multiple other classes. That's because reuse is the key benefit of extension methods, and if you only use an extension in one class, then it's going to be better to write a private helper method in that class. You can always extract it out to be an extension method if and when you find other places that you want to use it. Next, if you find a good candidate for an extension, make sure you're restrictive and select the most specific type in the hierarchy to extend. You can add extension methods to object, but it's very unlikely that every single object you ever use will need that extension. And the broader your extension method is, the more likely it's going to get shadowed by a class method with the same signature somewhere in the stack with unexpected results. When you know what to extend, you need to think about where your extensions will live. It's a good idea to structure your extensions into separate assemblies so that consumers can reference just the extensions they need. You could have some extensions to system types and some extensions to entity framework types, and it doesn't make sense to put them all in one assembly. Not every app will use Entity Framework, and it's not good to make consumers bring those dependencies in if all they want to do is work with strings. Within your assemblies, you need to consider the namespace. You should probably use your own custom namespace so consumers don't accidentally bring your extension into scope. But a lot of times that easy discovery is exactly what you do want. So in that case, you'll choose to adopt the namespace of the target type. We'll see what that means in the demos. Now, this isn't a recommendation to stick with one or the other, but the guideline is to think carefully about namespaces for each of your extension methods. Then there's the who, naming for your extension methods and sponsor classes. You need a descriptive name for your sponsor class, preferably use the convention that class names end with extensions. It doesn't make any difference to consumers, they don't see the sponsor class name, but it helps with maintenance of the extensions. It's quite difficult to search for extension methods in source code, so using a naming convention like this definitely helps. The method name itself needs to be very explicit. You want to make sure consumers know what they're getting, especially if there's a chance the extension method has come into scope unexpectedly. But you also need to minimize the risk that someone will write a class method that shadows your extension method in the future. So you need to have a name which is clear, but not too obvious. And lastly, here are some guidelines on how you implement your extensions. Most importantly, you should try to minimize dependencies, so you don't end up forcing a big dependency graph into the consumer, which can also lead to versioning issues. So if you use the latest version of the JSON.NET library in your extensions assembly, any consumers who use an older version of JSON.NET are going to be forced to upgrade to use your extensions, which adds time and risk. Of course, you can't always do this, but you should try to make your extension methods self-contained. And you should treat documentation as mandatory for extension methods. IntelliSense will show the XML comments for your extension, so make sure you include a summary which is clear on exactly what the extension method does. Okay, so those are the best practices which will help you get the most out of extension methods. I'll go into more detail about these during the module, but let's have a look at the impact of some of them in action.